is GATE 2023 Life Sciences Q section of biochemistry. 31st question. Given below are 4 reactions of glycolytic pathways. Glycolytic pathway catalyzed by enzymes E1, E2, E3 and E4 as indicated. Which of these enzymes are not part of gluconeogenesis pathway? So as you can see here, there could be one or more enzymes. So there is a possibility that the answer could be more than one. The answer could be more than one options given below. So what is glycolytic pathway? Glycolytic pathway is the pathway in which glucose is broken down into pyruvate. So from glucose we get pyruvate, and this is glycolysis pathway. Similarly, gluconeogenesis is formation of new glucose molecule, and we have this. So gluconeogenesis is from pyruvate we get formation of new glucose molecules. So these are the reactions given below catalyzed by respective enzymes. Fructose 6-phosphate gives fructose 1,6-bisphosphate, and this enzyme is this reaction is catalyzed by phosphofructokinase 1, PFK1. This is a very important enzyme of glycolysis pathway. So E1 is PFK1. Then we have fructose 1,6-bisphosphate gives dihydroxyacetone phosphate plus glyceraldehyde 3-phosphate. This is a cleavage reaction and this is carried out by enzyme aldolase. Okay, so E2 is aldolase. Third is 3-phosphoglycerate gives 2-phosphoglycerate. This is carried out by enzyme phosphoglycerate mutase. Okay, the third phosphate is shifted to second phosphate on the glycerate molecule, and the final reaction is phosphoenol pyruvate to pyruvate. This is the final step of glycolysis reaction wherein the pyruvate is formed, and this reaction is catalyzed by pyruvate kinase. Okay, so keep these reactions in mind. I'll show you the detailed pathway of glycolysis and gluconeogenesis. So as you can see, the pink one is a glycolysis pathway and the blue one is a gluconeogenesis. So even though gluconeogenesis is formation of glucose from pyruvate, we cannot say that gluconeogenesis is exactly reversible that of glycolysis. There are few different reactions from pyruvate to glucose, as you can see here. So the first reaction which is different is hexokinase. So from glucose to glucose 6-phosphate we have hexokinase, whereas the backward reaction from gluconeogenesis to the formation of glucose we have glucose 6-phosphate. So why these reactions are different? So there are 3 different reactions. This is second and this is third. Why there are 3 different reactions? For the different reactions in glycolysis and gluconeogenesis, because the delta G the delta G of the formation of glucose 6 phosphate from glucose is negative. It is up kilojoule per mole, is approximately kilojoule minus 20 kilojoule per mole. Okay. Similarly, these reactions also have a negative delta G value. And because of negative delta G value, the reverse reaction to form a gluconeogenesis pathway is not possible. So when delta G is negative, we consider it to be as spontaneous. Spontaneous reactions which occur in the cell, and when we reverse this reaction, the delta G will now become a positive value, which is not possible in the cell, and hence the cell chooses a different enzyme to catalyze this reaction, whose delta G will now be slightly less positive or negative, and thus the reaction is feasible. Okay, so as I mentioned, these three reactions are different, and as you can see, from pyruvate to phosphoenol pyruvate, we have one extra oxaloacetate here. From pyruvate we cannot directly jump into phosphoenol pyruvate, which is the first step of gluconeogenesis. We have oxaloacetate which is formed in between. So coming back to the question, phosphoenol pyruvate to pyruvate, this reaction in the reverse format does not exist, and hence the enzyme is E4D. Also, fructose 6 phosphate and fructose 1,6 phosphate, the enzyme I said was PFK1. But in gluconeogenesis pathway, this enzyme, the reverse reaction of enzyme is carried out by fructose 1,6 bis. So this enzyme is different and E4 enzyme is different. So the correct answer is A and B. Okay. So in glycolysis, E1 is present, E4 is present, but during gluconeogenesis pathway, these enzymes cannot catalyze the backward reaction from pyruvate to phosphoenol pyruvate. Why? Because delta G is positive, and hence it is not feasible. Thus, there are different enzymes which catalyze pyruvate. So we have oxaloacetate and phosphoenol pyruvate, and this is catalyzed by fructose 1,6 bisphosphatase. These enzymes lower the delta G and thus make the reaction feasible for gluconeogenesis pathway. Hence, the answer is E1 and E4. Thank you.